we're going to look at the first problem, and I'm going to use it to try and explain the mathematical induction as we go through. Because when I looked at it, this problem actually, what they were trying to do is walk you step by step through this process. So I'm going to use this, and I'm going to try and write on my screen at the same time. I've been playing with the iPad a little, so you please bear with me as I do it. What we're looking at is from our homework from 9.4, mathematical induction. We're looking at question 1. And so just the first thing we're going to start off with is just, the principle of mathematical induction. So basically, what we're doing is you're going to be given a mathematical statement. So in this case, this is giving you, if we want to add essentially multiples of 8, that's what we see on the screen here. So you have 8 plus 16 plus 24 and so on. That's just telling you the numbers. And n is always like the index or the number of those digits in this case that we're adding up. So like if you said this would be n equal to 1, this would be n equal to 2, n equal to 3, and so forth. So like this is our first, like, 8 times 1, 8 times 2 times 3. And this is really kind of like what you're doing to get each subsequent that you're adding for this particular one, okay? So you really want to look at it and try and see if you can understand that first. Over on this side, this is a formula where if you want to get, say, the first digit for 8, if you plug in ones here, you're going to get that that's 8. If you wanted to find the sum of the first 2 digits, then you would plug in 2 because that's the n. I'm looking for the first 2 digits, so my n would be 2. And you plug this in. This is a simpler, faster, quicker way to find that formula. But like we were talking about in class before the internet got super bad, and I apologize, what you want to do for this is to prove these things. Mathematical induction is one technique we can use to prove mathematical statements, or to prove like other things as well. But in this case, we're being given a statement, and we want to show that it's true. And for mathematical induction, here we go. I'm going to try and write this. What we need to do, and I may have to, I'm going to write, and I'm hoping it's going to catch up. It may be a little slow. I'm learning how to make this work. And if it doesn't, I'll import in just a second. There's 2 conditions that we have to check and verify. And that's what question 1 was having you walk through. So yes, it's coming up. It's a little slow. Just bear with it as we go. So mathematical induction, 2 conditions. So condition 1, and I'm just going to be writing these, and you want to be familiar with them, because once you understand them, and we're going to go through some, and you'll be okay. So condition 1 says, we must show the statement is true for the natural number 1. So we're doing this with regards to natural numbers. Our natural numbers are going to be like the counting numbers. So like if we were going to count the people in our classroom, we would start with 1, 2, 3, 4, and so on, okay? So we're going to use mathematical induction to show this is true for all natural numbers. The first condition says the statement is true for the natural number 1. So what we're going to do to prove this is we are going to plug in n equal to 1 and verify that the left side and right side of our equation is true. So what we're going to do is to show this, we are going to plug in n equal to 1 into the original statement and show that the left-hand side is equal to the right-hand side. And that's the first condition that we have to verify, okay? So it's going to catch up here in just a second. Maybe. Oh, there we go. So we're going to plug in n equals 1 into the original. So for us, the 8 plus 16 plus 24. And we're going to do all this together in a second. I'm just going to talk you through it a little bit first so we have an idea. And we want to show both sides are equal. And then if that's done, then we can say, condition 1 holds, or condition 1 has been shown to be true. Condition 1 is satisfied, is the words that we'll use. Okay. And then the next condition that we'll prove as well, and it's going to catch up here as I'm writing, so is condition 2. nothing to let it catch up. Mhm. Okay, good. So condition one is satisfied. Now condition two, and this is where it gets a little funny, which is this is the process. So you're going to trust me and you're going to trust the process. The second condition is if, and this is the big part, if the statement, let me scroll up a little bit, is true for some natural number k. And we want to show that it's true just for some random value. We're not saying it's true for 10, so it's true for 11. What we're doing here is we're going to say, I'm going to pick an arbitrary natural number k. I'm going to assume that is true. And so once we do that, then we want to use that. So that if natural number true, if it's true for some natural number k, we can show it is also true for k plus 1. Okay? So this is, hopefully this will scroll up. If it doesn't, I'll scroll up in a minute, but I've been scrolling up on mine. Okay? And so that means for us as we're doing this is what we will be doing then is that we are going to go through and we are going to, in our case, we're going to assume it's true for k. And I'll show you what that means in a second as we go through it. And then we're going to use that k statement that we're going to write to show it is true for the k plus 1, for k plus 1. And what they were trying to do here with question one, the very first part, so there's 7 steps here. We're going to go through it all together. I'll work it out, and then I'm going to show you how that correlates to this. I'm going to go slow because I know this is the part a lot of folks are having trouble with. And if you still have trouble, again, remember, I've offered, we'll go back and talk about it some more. But this first part is asking what are the two conditions. So those are the two that I just wrote here. We're going to match it up. So we have to always show that it is true for the natural number 1. So we show that it is true for that n equal to 1 case, okay? And then the second condition, so they want both of them. There's 2 of them, 2 conditions. And this is always true for mathematical induction. Is that if it's true for some natural number k, it is also true for the next natural number k plus 1. Okay? So those are the 2 statements you want to pick. We're going to check that answer. And there we go. Good. So the next part, they're trying to walk you through this process. And I know maybe it's a little confusing. The intention here was good. So what they're asking us to do, we've been given a statement. So our statement that we are working with here is, and I'm going to change my colors a little bit. Maybe the statement that we've been given is 8 plus 16 plus 24 plus, and then we've got some dots, plus 8n, and then it's saying it's equal to 4 times n plus 1. I recommend if you don't understand what it's saying, maybe stop and think about it, because if you understand the statement, it's going to help you when you're plugging things in, and it's going to help you to kind of understand how the formula works. And the more you've played with these a little, the more comfortable you're going to be. So for example, on this one, if I say, hey, if n is equal to 1, what does that mean? Okay. And I'm going to kind of walk you through. It's going to drop down here. So that's our statement. I just copied it from up here. My periods are a little big. I might want to fill those in. It's way bigger on here. So I'm just going to, those are just the 3 ellipses, that means continuing in that fashion. So think about it. If we took our n minus 1 case, right? And we said, and I may actually move some of this up so you can see it a little higher on the screen. So if I have n is equal to 1, in that case, my first value, that would be n equal to 1. It would be the first value over here. I'm looking at the first digit or the first value in my formula on the left. And that's equal to, and we're going to actually use this in a minute, but we would plug in 4 times 1, because again, n equal to 1, times, and then I'm going to replace n in the whole thing. Oh my, with 1 throughout. And so give it 1 second as it catches up. Mhm. So maybe try, okay, if we take that and we plug it in. So for our n equal to 1 case, we're looking at the first, we're adding one of those values, right? That would be 8. And then if we were going to work over on the other side, and we're actually going to use this in a minute, this working on the inside of this parenthesis would be 2. We're going to have 4 times 1 times 2. And, just kind of verifying, we're going to get 8 equals 8. And then if you wanted to do the second case, n is equal to 2, you're going to do the same thing. You're going to add the first 2 digits. So in your sequence, 8 plus 16. And then the formula is just a faster way to do it, because when you're adding these types of digits, these are formulas that people have found that would make the process faster, but we're verifying that is a true statement. And this is something mathematicians have to do. Just like I was telling y'all, some of you that were in class, in math, it's very much like science or anything else. We can't assume anything. Nothing that we do is an assumption. Everything has been shown to be proven. So if you think back, like if you learned about the distributive property in a class and we're like, look, we have, the distributive property written out in certain word form. Um, and then all of a sudden we're like, hey, look, that's we write it out. I'll show you. Like it's because somebody had to show that that was true in order for you to be able to use it. So I went ahead, 8 here would equal 8, and then you're going to have 4 times 1 plus the 2, and then 8 is equal to 8. Now for the n equals 2 case, you're going to have the first 2 digits, so 8 and 16, because n equals 2, we're doing the 2 of them. And then you can, on the right side, you'd plug it in, and you should get something that's true. So this is times 3, and you have 4 times 2. So that would be 8 times 3, which equals 24. And that's what we would have gotten on the left-hand side as well. Now, you're not going to do the process this way. I just wanted you to kind of see how these things come together, because if you understand the way it's written, it's going to pop up here in just a second, then I think the next process is going to go much better for you, okay? So it's going to, 1 second. I'm trying to figure out a way to make this a little faster to project it, but because there's so many words here and I wanted to show you how the two align, try and add that up, maybe simplify it on your own, and then my work's going to pop up. So go ahead and add within your parentheses and then try simplifying the multiplication and make sure you get the same number on both sides. And mine's going to pop up here as well. 8 plus 16 will give me 24. We would combine inside my parentheses first order of operation, 4 by 2 gives me 8, bringing down the 3, 24. Okay. Now coming back to what they're asking us to do over here. So over on the screen, it's saying show the first of these conditions. So if we go back up to the top, let me scroll back up right here. If we scroll back up, condition 1 is the statement is true for the natural number 1. So what they're asking us to do is to show the first condition is satisfied by evaluating the left side. So we're going to evaluate the left side for n equal to 1. And we actually kind of already did this, but we'll talk through it in this way too. And evaluating the left and right sides of the given statement for the first natural number. The first natural number is 1. That's going to be n equal to 1, okay? So we actually have already done this. This was what we did right here on screen. So this is our first case, and this is what they're asking you to do, right? So this is going to be this part 2, if you will. So I'm just going to kind of highlight it in a purple. And so what they're asking you to do, the first case, is we're evaluating for the natural number 1. So what you're going to do is you will plug in n equals to 1. You're going to plug that into both sides of your equation, just like what we saw here. And I'm adding some extra words to the notes so you can see that. So you're going to plug in, okay? So if we look at what we have here, 8 is the first number. So I'm going to bring the 8 over because that's the first index. That's the first one we looked at. Then I'm going to ignore these. I don't need these yet. Okay, so the first case we're going to evaluate for natural number 1. So plug in equals 1 in to our equation. So the first number on the left is 8. That's all we need, the first value that we're doing. And then on the right side, everywhere that we have an n, we're going to replace it with parentheses, just like I've done. And then you're going to plug into those parentheses that 1 that is the natural number that we're evaluating it for. So n equal to 1. So we've done this. We have 4 times 1. And then inside the bracket, I put brackets here instead because I added parentheses for the n. You're going to have a 1. 1 plus 1 gives me 2. And then dropping everything down, 4 by 1 by 2 will give me 8. So 8 is equal to 8. And so this is that first part. Now they do want you to simplify. So what you will type on the computer is this simplified part right here where it says 8 equals 8. Okay? So this is what we will fill in on the computer. So fill in on the computer. Okay? And that's going to pop up there in just a second. So I'm going to go ahead and start typing it in while we're waiting. And then we can go ahead and check that. All right? So they just want you to evaluate the expression you were given, or the statement in this case, because it's got an equal sign, 8 equal to 8, okay? Evaluate the expression on the left, the expression on the right, when it's equal to 1. So we're going to fill that in on the computer. That's that first box. Okay. So for this second condition, I'm going to drop down. This is not the second condition. This was just me playing around with it, trying to show y'all. I'm going to drop down and add some more things here. So what they're asking us to do for the second condition. So to show the second condition satisfied, we're going to use the k, you have to show it for k plus 1. I actually do this in a little different order. So I'm going to kind of talk you through how I think about doing it and maybe how I was taught, and then we're going to plug those things in here. So the second condition, if you look back at your notes what we talked about, our second condition would be to show if this is true for the k or k, for a random k that belongs to a natural number. So a k that's a natural number. So to do that, what I do is the way they did it here, I don't think it's bad. I just think it's a little more confusing than maybe, I don't know, to me, the way I think about it. You may do it either way once you understand. You don't have to necessarily do it the way I'm showing you. What I'm going to do is I'm going to say, that means I'm going to assume that it's true. For me, I assume it's true for k. That's how I think in my mind. I'm going to say, assume that it's true for, like, where n is equal to k, okay? So just some arbitrary random k. So let's think about if we were going to do it for some random k, looking at what we started with. Now, originally we had 8 plus 16 plus 24 plus, I'm going to put some dots in here. It's going to catch up in just a second, you'll see. So the first thing I did is I just rewrote, I'm going to rewrite my expression. So I'm going to assume that if it's true for some k to the n. So this is that first part of the second condition, okay? I'm going to assume it's true for n equal to k. So I'm going to I just rewrote this first given statement. And what I'm going to do is I'm going to think about what that means. So I'm going to keep my 8, and I'm going to have a 16. I'm going to have 24. So all of those are going to be included. Okay, so I'll keep my 8, I'll keep my 16, I'll keep my 24. I'm going to keep the ellipses, and then instead of n, what I'm going to do is I'm going to plug in k where I had an n here, okay? So if I have 8 plus 16 plus 24 plus dot, 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 it's going to be 8, and instead of n, I want to plug in k. So that's kind of, I'm going to back up real quick because the way I wrote it was too big. I'm going to have to move a little to the left from running out of room. So 8 plus 16 plus 24 plus, you're going to have your 3 ellipses, 8. And then instead of n, I'm going to have a giant parenthesis. And I'm going to plug in the k that they're telling me to evaluate. And I might even make it like a nice green so you can kind of really see. So if we scroll down, what I've done is I've carried these down because k is going to be some arbitrary value. I don't know what. So instead of n, I want to say, hey, I'm going to evaluate that when n is equal to k. So I'm going to plug in that k. So I made k green. It should pop up any second. And I'm going to plug it in here instead of n. So go ahead and try that on your own. And then on the right side, I want to do something similar. 4. And then everywhere there's an n, I want to plug in a parenthesis. So I'll just bring a k. On the right-hand side, by a similar idea, I'm going to say take the 4 and bring it down. I'm going to put a parenthesis for n. I'm going to open my brackets, have an, and I can probably make this a little bigger maybe if I need to. I'm not sure if that's why it's off the page. It was a little weird. You're going to have a bracket with your parenthesis plus 1, just like this. And inside each of those parentheses, you're going to place the k. So go ahead and do that on your paper. Now, this is not what goes in the box over here on the right. Please don't just do this on the computer. You really want to try and understand this. The more you learn it now, the less that you have to try and cram or practice as you're going to the final and for your practice quizzes and whatnot, okay? So if we're assuming that it is true, this is going to be for my n equals k case. So let me make sure that it's updating. It should have already done it. It's going a little slower. Apologize. Not sure. Let me double check this. Yeah, I think it's still updating, so just give it 1 second. What we will do is we will come down here and I'm going to start. I'm going to see if I can help it along because it's being a little slower than I would like. I don't want to lose you. Oh no, I'm concerned. Let me just make sure that it's doing this. I never did this for years. Putting my keys inside of there. Oh my. Let's see. Hopefully that works. It's not filling it in anymore. Okay, so there. All right, so it went ahead and did it. So I paused for a moment to try to make sure everything reconnected. So we got the 4, we've got our k, we plugged in k plus 1. I'm going to simplify this, and this is for the k case that we're going to assume is true, okay? So on the left side, we will keep our 8 plus 16 plus 24 plus, we have those 3 ellipses dots, 8k. And then on the right side, we'll have 4 times k, and then that'll be k plus 1. This is not the first blank over here on the right side, so please don't type that in. It's going to mark it wrong on the computer. I know that. Okay? So just, follow along. I'm going to explain why I'm doing it the way I do it, because to me, this makes sense. So I do my k case, because I need that. So this is going to be my k case right here. And then it'll be in green. So give it 1 second. Again, it's updating. While it's doing that, I'm going to start working on the k plus 1. So k plus 1 case will also be similar. And hopefully this is what you got when you simplified. You're just rewriting this as 8k, 4 times k, and then k plus 1 without the parenthesis around the k. So now we want to do the same thing going back to this part up here. So we have our 8 plus 16 plus 24 plus. Now, when we're doing the next one, so just maybe follow along for a second. I kind of refreshed it because I need it to show. We're going to bring down everything that we had here. And then we want to add one case beyond that. So we'll have 8 plus 16 plus 24 plus those ellipses plus your 8 and your k. And then we're going to go one case beyond it now. So that's what we have right here. We want to add an 8 times k plus 1. And that's going to be the k plus 1 case. So it's the same thing. We're just adding one extra, in this case, summation of 8, one multiple of 8 to it. And I'm going to have to kind of layer mine just because of the way my paper is set up. I'm going to have my 4. Now on this side, we're not adding one beyond. We're changing what part of the formula we use. So we're going to have our 4. And then again, think about going back to your n. And everywhere there's an n, we want to replace it with parentheses. And we're plugging in n is equal to k. Okay? So everywhere that n, we're going to have, this is going to catch up in just a second, but you'll have an equal sign and you'll have 4. You're going to have a parentheses where you had an n, just like what we did with k. And then you're going to have a bracket. You're going to put a parentheses around your n plus 1. All right? So it's catching up. I'm going to pause this real quick until it. Okay. So what we've done is we took our original. I'm going to bring this down so you can actually see more of it on one screen. So we took the original value that we were given, our 8 plus 16 plus 24 plus, we have our ellipses plus 8n. But we want k plus 1, so we want to include k and then k plus 1, because those are going to be the last 2 terms of that side. If you do the k case, you're just going to add one more to get k plus 1. And it's a good idea to do it in this form because this helps you see, how to break these things up in a second. There's a strategy behind this, I promise. On the right side, you have 4, and since we're doing the k plus 1, everywhere there was an n, we put parentheses when we plug in. Because on this side, this is the formula. This part over here is the actual numbers we're adding up. And then on this side is the formula that gives you the same value without having to add each of them by hand. It's kind of like a shortcut. And we want to make sure our shortcut matches the actual formula that we think it should, or like the summation on this side. So now everywhere that you see that, what we want to do for this one is we are going to plug in our k plus 1 everywhere that we have that parenthesis. So you want to go ahead, plug k plus 1 in here, plug k plus 1 in here. And I knew I put it underneath. It was just getting too long on my paper. I suggest writing large. I suggest using one sheet of paper, maybe 2, but I would write on the front only. You can have multiple sheets as you do these tests for sure. I write big. I don't remember things. I look up at the top. So, whatever you got to do to make sure that you're getting it right, okay? So plugging in k plus 1, we're not quite done. Now we need to simplify this. So I'm going to try and get it all in one line before I circle it all. So try and simplify. The left side's good. You're just going to rewrite that below. Plus 16 plus 24 plus ... plus 8k plus 8 times k plus 1. We don't factor over on the left side. What we do want to do is simplify inside that bracket on the right side, okay? So what I mean is I'm going to keep my 4 and my k plus 1 term, right? And I'll keep the k plus 1. If you scroll down, you can kind of see what I'm doing. So I'm just rewriting this again one more time. I'm going to circle it so you can kind of see them together. And I'm going to have plus, and then that's multiplying. Sorry, not plus. I need to simplify this bracket. So k plus 1 will just become k plus 2, which is what we anticipate if you look at the original formula. Because the original formula was n and n plus 1. So you're taking whatever your n is, and that's your first. So our n is k plus 1. And then we're taking that in and adding 1. So if you have k plus 1 should be k plus 2. And again, that's about to pop up here for you in 1 second. Oh, it did it right when I was about to pause it. So that's going to be the k plus 1 case, okay? And so this is actually what they want in that box there. I like to do them both because to me it makes more sense to have this and then just add one on here. I don't know, it's just easier to show you that way. For my mind, it works a little better. But we're going to need both of these, okay? So this is our k case. So I'm going to scroll up a little. So this is my k case, right? This is when n is equal to k. This is my k case. at the top. And then the one down at the bottom is my k plus 1k. So just keep those straight. You can tell based on what's inside of it. You know, you got a k here, you've got a k and k plus 1. So you just got one additional value you're adding. Okay. And there'll be some additional highlighting here you'll see in a second where I made a little more notation. But what we're going to talk about while we're waiting for that, I'm going to kind of shrink this down just a tiny bit. So k plus 1 case just has k plus 1 added to the k. Over here, k plus 1 and k plus 2. You can just see it's one factor beyond on each of those, like one extra. Now, to show the second condition, write the given statement for k plus 1. We have the k plus 1. We have this right here. So go ahead and fill it in. They want it in factored form. So I've given it to you in the factored form. And you want this factored form because we're going to use this with this case right here to simplify the rest of it. So what's going to happen is the factored form of this would be 8 times k plus 1. Over on the right side is going to be 4 times k plus 1 times, and that'll be k plus 2. And then, so that's exactly what we had typed down here or what we'd come up with. And that's what I'm going to type into my boxes for this because it's asking for k plus 1. That's what we just found. I'm going to check it. Boom. Sarah did boom in class. That was awesome. I do that too. Now they're having you to restate this. They're having you restate real quick. So let's just read it together. If the statement for k plus 1 is true whenever blank, the given statement blank is true for all natural numbers. So k plus 1 is true whenever this is your k holds for some k. So it's the statement that we had for the k case up here, the regular k case. That's what the statement is they're looking for there. So they're out of order, but for me, it makes sense to create them in this way. So just keep in mind on the computer, this will go in that k plus 1 box that comes first. And then this is going to go, and I'm going to make this bullish, okay? So this is the computer. This will go first. This bottom part right down here, you'll see in just 1 second. And then the top part's actually going to go in the computer second. Because for me, the k case is easier if you have the k case to build on it to it for k plus 1. That's how my mind works. Again, I mean, however it works for you. So this goes first on the computer. That was what we just typed. And then you're going to use this one for the second. This is for the drop down. Okay. Oh gosh. I just lost my notes. And that's that drop down. Okay. So I'm trying to make it really clear what goes where. I might actually clean this up a little because I feel like that's too messy. So this is the first k plus 1, fill in the blank. Okay, I don't know. That's actually just really messy in general. I think you get the idea. I won't belabor that too much further. But that this will go in the first blank for the next part, okay? And then the k case that we have up here, yeah, we'll go. So we're gonna pick the drop down that matches that, and I think that you'll see that. So the drop down that's gonna match it is this one right here, as long as that holds for some k. So KK second drop down, this is the first blank that you fill in. So they're backwards, but to write them out properly, that's how I've always done it. It makes sense to me. I get what they're doing and why. So double check. Excellent. Great. So far we're pretty good. Now this is the part, just we're going to go with it. It's not hard, but it's just a little different possibly. So this method, what we are going to do, what we want to take this equation right here, and we are going to try and show by manipulating first the left-hand side, which is what they say, use this statement for k. So we are going to use this statement we have right here. That's the k statement. And we're going to use that to simplify this statement over on the statement right here, okay? So to simplify the left side. So we want to use it for the left side. So what does that mean? Let's clarify this a little. So on the left side, and this is why I like to write it out the way I do, and that's why I like to drop everything down like I do. If you look at what's going on this side over here, we have 8 plus 16 plus 24 plus dot 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 plus 8k. If we look at that, that is the same as our entire K case, right? So this is my K case, right? This is the 8 plus 16 plus 24 plus dot 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 plus 8K, right? That's my K case. And what do we know? That is equal to, from the K case above, that side is equal to that 4K times K plus 1. So I'm just going to pause for a second while I let y'all look at that. Okay. So these numbers, this first part right here, is the same as this, right? That's my K case. So I know that these numbers that I have are the same as that 4K plus 1, 4K times K plus 1. So what I'm going to do then is I'm going to replace it with 4 times K, oh my, times K times K plus 1. I'm going to leave the right-hand side alone. So I'm just going to start with that left-hand side. They're walking you through it. 4. So I'm going to replace it with the 4K plus 1. And then I almost forgot something. Let me erase this real quick. We're not done though. We're replacing it, but what was left? Well, what was left was my plus 8 times K plus 1, right? So we were able to account for the first 8K terms that were being added by rewriting them as 4K plus K plus 1. And then behind them, I'm able to say plus 8 times K plus 1. So that's going to pop up here in just a second. And then while you're doing that, yeah, next we want to go ahead and drop down everything else on the right side. We didn't change that. So on the left side, all we're doing is recognizing that the first K terms are the same as the KKs that we had, I'm sorry, up here. And we were able to then replace them with this using the fact that we're assuming that's true. We know that's true because we said that's true. That's an assumption we made. And then over on the right-hand side, we're leaving it all alone. So instead of 8 plus 16 plus 24 plus et cetera, plus 8K, how many ever there are, I'm going to say, I'm going to use the fact that that's the same as my K case, and I'm going to replace it with what I know K case was equal to, which was my 4K plus 1. 4 times K plus K plus 1. La, 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 la. The English is failing me, but I think you'll see it hopefully on screen. Okay? So that's what they want you to fill in on the computer as well. So that's all we're doing. We are going to say, do you see how we have 4? Be careful and make that what you, that's why I like to do it myself and then match it up. So you're going to put a 4 here because it's 4 times K plus 1. And then here it's going to be plus 8 times K plus 1. So you're going to fill those in and you're going to check your answer there. Awesome. So far, so good. And now they're telling you what to do. So they're helping you learn how to do induction. So what we want to do is now that we have replaced it and it looks starting to look similar to what we have over here, we want to do some algebraic manipulation on the right side to try and make a match. Okay, so our goal is to show that these two sides are equal. I'm going to clean this K up. It's bothering me. It's a little something. Okay, so looking at what I have, what I see right away is that I have a K plus 1. Do we see this? I have a K plus 1 here. I have a K plus 1 here. So K plus 1 here and a K plus 1 here. Actually, I'm going to change this to a different color just so it's really clear what I'm doing on this stuff. One here. So K plus 1, K plus 1, K plus 1. Do you see how all those match up? So I'm going to try and use that. And so they're showing you how to do that. They make a suggestion because this is us teaching you. It's the first time you've seen it. It's kind of like training wheels. There's a lot of steps and things put in place to help you. What we're going to do, and I might zoom in to try to make this bigger so you can see. You have 4 times K and K plus 1 plus 8 times and K plus 1 equals. So they're going to have you make some stuff up, like use some distributive rule and rewrite it to make it look like the other side. Well, what I want to do here is I know I have this K plus 1. So I'm actually going to use the fact that multiplication is commutative and associative. I'm sorry, I can do it in any order. And I'm going to rewrite taking my 4 on the right-hand side and putting the k plus 2 with it. And then I'm going to leave the k plus 1 that was there. I'm going to take it and put it at the back for right now because I'm going to leave it in purple because that's what I want. That's the one I was using. So I'm going to rewrite this multiplication on the right side. So 4 and k plus 2 are together. I'm going to leave my k plus 1 at the back because I know I want a k plus 1 in 2 individual terms, okay? And these are things you don't know because you've probably never seen this before, but that's why we're going really, really slow and walking through it, and that's why there's only 5 problems, and they walk you step by step through that, okay? So the k plus 1 is going to pop up here in just a second. Perfect. There we go. So what I want to do now, I'm going to leave this left-hand side here for a minute and just focus on the right. I'm going to take this 4k, and I am the 4 and the k plus 2, and I'm going to distribute it like they suggest. And I mean, even without that, if you look at what's going on the left side, we have a 4k and we have an 8 in front. And if you look at we've got a 4 times a k, and we've got a 4 times a 2 if we distribute. So, I mean, right away you kind of think, okay, I want to try and get an 8. I want to try and get a 4k. And that's where, like, when you get in the higher classes, it can get challenging if you do, like, some of the math classes with some of the proofs is the things we do. But I'm going to distribute this. You're going to get 4 times k, and then you're going to get plus 8. Okay? So go ahead and we're going to multiply this, and you're going to get 4 times k. And then you'll also get an 8. And I'm going to use some colors here. So when I multiply the 4 by k, I'm going to use blue. I'm doing this on purpose. When I multiply it by the 2, I'm going to use the pink because I'm trying to make some things match up here. See? So I started to do it in blue and I erased it. And I'm leaving that for the k plus 1 at the back in purple for now. Oh my, well, I was trying to. That didn't quite work out. Okay. So we're going to have our 4k plus 8 when we distribute, and I'm going to leave k plus 1. So distribution, I know a lot of times we take it and we multiply it all the way through like we FOIL. We don't have to FOIL these. If you've ever done the EC method for factoring, we do it in pieces instead. So what we're going to do is we're going to use the fact that this is actually 2 separate. And I'm going to do 4k and multiply it individually by a k plus 1. So let me give it 1 second. So I'm going to take the 4k plus 8, the k plus 1's here. I'm going to take 4k and I want to show that I can multiply it in front. And that's like a part of my distribution. So I'm going to have 4k times k plus 1. And I'm actually going to, I'm going to leave it in a factored form for the k plus 1 because I know I want that. So take your 4k and write it. And then you're going to open a parenthesis with k plus 1 and close it. We're not actually going to do the full like FOIL distribution. And again, this is not something you would know. You're not, because you're learning this right now. That's why we're doing it together. So when you distribute, you can multiply 4k by k plus 1. You can multiply 8 by k plus 1. FOIL is just another way to do that. But we're not trying to do that. We want a factored version of this. So that's what the first term will look like. You're going to have 4k multiplying the entire parenthesis. And now I'm going to do the same process, taking my 8, so plus 8, and then it'll be times k plus 1 as well. So it'll look similar to what I have there. So maybe try it. If not, you can hold up for a second. While that's happening, I'm going to bring down the other side. And I guess maybe I could have left the k plus 1 in purple because that's that same k. Oh, goodness. Oh, no. What did I do? Sorry, I accidentally, my screen went blank for a second. Okay. So I'm actually going to, the k plus 1, I was leaving it. It's okay if it's not in purple, I guess, but I might do it just to, so you guys, because I said I was going to for a minute. Just so you kind of see, that's that same k plus 1. I'm just dropping it down without foiling it fully. So this, if you've ever done the AC method, like you get those 2 terms that match, and then that's your other factor. It's just kind of that process in reverse, okay? So what I've done is I've just multiplied 4k by the entire binomial and left it out front. Same with my 8, I've multiplied it and left it out front. But if you look, now we have both sides are equal. And that's what we want to do. Because at this point, if both sides are equal, if our left-hand side matches our right-hand side, then we can say that it's true for both conditions. So what they're going to have you do here is fill in and pay attention, because I wasn't paying close attention. What you end up getting is this 4K here, and you're going to get that 8K there. Okay? You're going to get the 8K there. So you're going to take those numbers, and I'll maybe shift it over. And I just dropped this stuff down so you can see now that both sides are equal. And we are going to check that answer. Sorry, I made this really big. If at any point you need to pause or rewind, please do. And then this is our very, very last step. So at this point, we are essentially done. This is, we could therefore say, by induction, we've shown that it's true for the natural number 1, and that if it's true for the k case, it's also been shown to be true for the k plus 1. So let's see which of these fills that in correctly. Since this statement is true, no. Oh wait, yes, okay. So we are first, so to me it's a little confusing too. It's just learning the words, because this first piece is going to be talking about the condition 2. And so let's talk through these. Since the statement is true for all values of k, the second condition required that is not right. How about since the right hand, that's not it either, right? Because it's not that the right hand side simplifies the left hand side. It's since, what? Wait, is there another one? Since is shown true for all values of k. Okay, this is the one that we want. I'm sorry. I had to think about it. So they're saying that it's been shown true for all, because that's what this assumption is here. Sorry, I just had to see what they were saying, because I saw the k plus 1. I assume we're bringing that in. So what they're saying is, if you do this, so if we assume, or if we show, I'm gonna use the same words. So if this is true for k, and we can show it's true for k plus 1, then that shows that it is true for all k, for all natural numbers k. So that's the assumption there. All natural numbers k. So that's what we're looking for the verbiage there. Sorry, I had to reread that real quick. And this is going to pop up here for you. So since it's true for all values of k, the second condition is true. The first condition is also satisfied. That's what we showed earlier. And I'll show you the words in a second. So the given statement is true for all natural numbers. So once you have both conditions, so we showed the second one, that overall. So because this results, then this shows that it's true for all natural numbers. Good. Since it's true for all values of k, there we go. Final check. Excellent. It's going to move us on. I didn't want to do that yet, but that's where we are. This was a little longer than what I had anticipated, but I really wanted to walk you kind of through it. So I think I'm going to do this for tonight. I'm going to ask you to try this and maybe try number 2. I'll work on getting some of the other ones out to you tomorrow. I'm going to play with the iPad and make it go a little faster as well. But if true for k, we can show it's true for all, k plus 1, that's condition 2. And when we do that, then that means then we know. So that shows, I'm going to change this. That actually means that it's true for all the natural numbers k, okay? And that's that condition. So it's true for all values of k. So actually, I'm going to take this then show off, because we've already shown it. So that means then it is true for. So then it is true for all natural numbers k. Perfect. And so this will be in the notes. I will send this out with the video tonight for you all. And if you have questions, try this one and try number 2 just to get a sense. And then if you're having questions. But I do, it's a really important skill for plugging things in and being able to work with various forms like this. I'm assuming if y'all are in this class, you're probably going to need possibly business calc, or you're probably going to go into calculus. So you want to really make sure you understand these things, okay? All right, and that's it.